Okay, so getting into actually doing the stream ordering task, you're going to be asked to be able to figure out why this is a second order stream, why it's a first order stream, and you're going to learn that terminology of first order, second order, third order stream. So how do we do this type of thing? So I got this marked here as an X, got that one marked as an X, these two marked as an X, that marked as an X, that one marked as an X, because we're going to do those together. So if you're curious in learning more about how to do stream ordering, I'll pull up just some images here. So this is called the Strahler Method, is the method that we're going to first teach here. Now there are other ways of doing what are called like hydraulic or hydrologic unit code or hydrologic unit classifications called HUC codes. But we're going to use the Strahler method because you're in environmental health. If you're going to hydrology or aquatic ecology or something like that, you may need to know the other classification schemes. And here you can see Strahler, Horton, Shreve, Hack, topological. There's a bunch. The Strahler method seems to be the one that I think you might interact with the most. So let's pull this up. So how does it work? So a 1 and a 1 have to come together, become a 2. So a first order and a first order stream become a 2. And these first order streams, it's sometimes debated what's a first order stream. You know, in logging, if you're logging near a first order stream, you know, the forestry folks working with the logging operation will tell them you're not allowed to log within a certain distance, or if you do, you have to take certain precautions not to damage the water quality of the stream. And mining, if they want to pour dirt and fill in a second or first order stream, they might just call it a ditch. Other people will say, no, this is part of a system here, and what you do here impacts the whole thing. So a lot of valley fills on strip mining occurred near first order streams. When people want to build homes or do development, they might want to just fill these in so they can build homes. So there's a lot of debate, and it takes special approvals if somebody's going to fill in a first order stream or even a wetland. So first order streams are kind of like the streams that start off the whole system, and the combined effects of a lot of first order streams can have an immense impact on the higher order streams, like our third, fourth, fifth, sixth, seventh, eighth order streams. It's not necessarily the Mississippi River where it meets the Gulf of Mexico near New Orleans that causes the zone of hypoxia. It's a combination of all the cumulative effects of all the first, second, third, fourth order streams, everything that runs into the Mississippi River that causes those effects. So how do we number? So again, it takes a first and a first to become a second. It takes a second and a second to become a third. A second and a third do not necessarily make a fourth. You have to have a third and a third come together to become a fourth. A third and a two coming together, it's still a third order stream. All right? We're going to go through an example here in a second. And just to give you some perspective here, the Ohio River is an eighth order river. The Mississippi, where it comes out at New Orleans, or where it goes into being a delta, is a 10th order river system. How big is the Mississippi? Well, you have to think it takes the Ohio River and an Ohio River, or you could think of probably the Ohio River and the Tennessee River coming together becomes a 9th order. And then presumably the Mississippi is either a 9th order right there, and when they come together, it becomes a 10th order. It may be when the Missouri River comes in. I'm not 100% sure. But it really essentially takes, you could think of like 1, 2, 3, 4 Ohio rivers coming together, 2 at a time, to become a 10th. The Amazon is so big that you could think of like the Mississippi River coming together with a Mississippi River would make an 11, and then 2 more Mississippi rivers coming together making an 11, and then those 2 coming together making a 12. So the Amazon is a humongous river system. The Nile may be a long river, but in terms of order, the Amazon is the largest in the world. I believe the Mississippi, even in terms of order and volume of water, is larger than that of the Nile. So how are we going to do this? How are we going to number these? I'm going to pull up an example here. All right, and then I think I can get this screencast to let me pull up a special tool. Okay, so we're going to go through the Strahler method here, and again, this dotted line here is just for your, on a quiz or something. Like this high line, this is a high line, not an intermittent stream. This would be a divide line or a ridge line. With regard to numbering our stream, which is the solid lines here, we're going to say, number 1 here, number 1 here. And I want to emphasize, if you look at a topographic map, you're going to see dotted lines. Those dotted lines on topo maps are intermittent streams, streams that don't flow all the time, or ephemeral streams, they flow certain times of the year. On this quiz question I asked on 2A, what's the highest line? This is a dividing line, what's it called? And you would say ridge line or whatever. But all right, back to the exercise at hand. So we're going to go through and label all the outside ones first. 1, 1, 1, 1, because all these little ones, the highest order, or not the highest order, but where it starts, these are all first order streams. First order streams. And what's the shape of this? It's kind of bushy, but it's dendritic, tree-like. All right. Once we've went through and labeled all the outer ones, we can then label n more. So a 1 and a 1 come together become a 2. A 1 and a 2 come together, guess what? That is still a 2. A 1 and a 1 here is a what? It's a 2. A 2 and a 2 coming together is a what? A 3. 2 and a 2 become a third order, so increase in order of magnitude to a 3. A 1 and a 1 is a 2. The 2 goes down and meets the 3. It's a 3. It takes a 3 and a 3 to become a 4. A 2 and a 3 are a 3. So on the quiz, it says, what's 1A? Your answer would have been 3. All right, a 1 and a 1 come together, that's a 2. A 2 and a 1 come together, that's a 2. A 2 and a 3 come together, it's not a 5, it's not a 4, it's not a 3, or is it? So a 2 and a 3 come together, it stays a 3. It can't get smaller. All right, a 1 and a 1 become a 2. A 1 and a 1 become a 2. A 1 and a 2 stay as a 2 down here. The 2 and the 2 come together, and that becomes a 3. A 3 and a 1 stays a 3. And a 3 and a 3 come together and become a 4. And that would be the answer on that quiz for 1B. Maybe you want to go down further. A 1 and a 1 become a 2. A 4 and a 2 stays a 4. So hopefully that practice was helpful. I always tend to work myself from the out and work my way in. And you might have a quiz where you've got to kind of number these things, or be able to take an example where it's mostly filled out, and it'll ask you what number to expect next. All right, so we're going to do a really quick review. I think I've got some slides to pull up here for some review questions. So for these first few review questions, we'll get to them the next time. Now, what separates watersheds from one another? Those high points, we call them ridge lines or divide lines. We're going to deal with the flooding questions in a future video. You should be able to label stream orders. So what's the highest stream order in the world? Which river has it? It would be the Amazon River, and you should be familiar with, the 8, 10, and 12. what do Europeans call watersheds? So from the last one, we call them catchments. Big point here from this video is you need to be able to label and recognize stream orders. Which one's the smallest, first order or fourth order? You know, so first order streams are those small, almost ditch-like or very small creek-like streams. All right, so that's going to be all for this section, and I'm going to put up some more information about how we're going to meet for the lab, and I will talk to you soon.